Hello everybody and um, welcome to the module. My name is Human and I will be running this series of lectures for the data warehousing and business intelligence module. So this is our first lecture in this context, and we are going to learn about a few concepts. So we are going to start with the we are going to address the basic concepts of the data warehousing, and then we are going to talk about the elements and the components. And later in this lecture, we will address or compare different methods of data storage and what's the meaning of metadata, and also we will finish this module, this lecture, by talking about or getting to know a few aggregation functions. So let's start with the concept of data warehouse. So a data warehouse is a large collection of business data that are used to help an organization for making decisions. The concept of data warehouse has existed since 1980s, when it was developed to help transitioning data from different powering operations to fueling decision support systems that it was tightly related to reveal business intelligence. The large amount of data in the data warehouses comes from different places, such as internal applications. We can call it, let's say, we have marketing department, sales department, finance, customer facing apps, and any external partners that are engaged with the system and others. A data warehouse can be defined as a repository which provides access to integrated data. This provides tool sets for managers and decision support analysts. The data might be captured over the time, which is a very important concept. So the data might be captured over the time, like variations in temperature, humidity, stock price over the last few decades, over the last few days, over the last few months, and so on. Also, the data might be stored in a form that some additional unnecessary data is attached to it. So when we want to form the system, it is very important that the unnecessary data should be dropped, and only we stick to the amount of data that it is relevant to the business. So with this concept of dropping the data, we call it reduction in the dimensionality of the data. We will get back to this concept later in the future lectures. So we can say that on a technical level, a data warehouse periodically pulls data from apps and systems, and then the data goes through formatting and the importing processes to match the data with the data that we already have in the data warehouse. The data warehouse stores this processed data, so it's already prepared and it's ready for those who are making decision available. How frequently the data pulls occur and how the data is formatted, all of these will vary depending on the need of the organization. Some organizations, let's imagine, for instance, in terms of the government, UK government, some data, it's been produced to be archived. Some data, by nature, it is the data that the government needs for making the decisions in the future. So it is the amount of data wrangling and data manipulation and the expectations that we have from this data warehouse that we are designing. It is tightly related to the interactions or the scenario that we are designing, and based on that we are forming the data. In some cases we might have a database, but we are not necessarily interested to design a specific queries or reports and so on. So we can just archive them and just store the data on different architectures. I will get back to it later in the future videos. Organizations can get more from the analysis parts by moving beyond just simply store the data into the databases and just applying data warehouses, creating schemas and so on. So it's very important to find out or figure out the right warehousing solution that fits for the business needs, that using these they can make a huge impact, or this applying specific scenarios, finding the right warehouse and so on, so it can help us that the company effectively serves its customers and also serves its growth in terms of the operations and services that they provide. So data warehouse is based on relational database management server, which is a central information repository that is surrounded by some key components to make the entire environment functional, manageable, and accessible. There are mainly 5 components in a data warehouse. We have the data warehouse data set, we have sourcing, we have acquisition, we have cleanup, and we have transformation tools. We call it, the abbreviation is ETL, which stands for extract, transform, and load. Also, we have another section which we can call it the metadata, or the analysis that has some data that is related of the maintenance of the data warehouse. So let's focus on the ETL part a little bit. The ETL tools are used for performing all the conversions, summarization, and all the changes needed to transform data into a unified format in a data warehouse. Their functionality include anonymized data as per regulatory stipulations. So we have some rules in terms of data formatting and the procedures. So ETL, we apply the tools that we have in the ETL to make sure that the data integrity is there. Also, eliminating unwanted data in operational databases from loading into the data warehouse. And also we have search and replace common names and definitions for data arriving from a different source. So The design of a data warehouse that we have, let's say for storing users' feedback on a system or in a business, we have a system, we have organized the data, we have designed different tables. However, when we are importing data from an external source or from a branch customer, maybe they are not following the rules or the design that we have. So in the ETL process, we go through this transformation process or procedure to make sure that we are not going to have sort of data structure mismatch and so on. Apart from this, we can calculate summaries and also derive data. And in case if we have missing data, we will be able to populate them, or in some cases we can go through some advanced strategies and impute the missing data. And also, if there are duplicated data, this is the stage that we try to resolve this data duplication. The integration layer integrates the disparate data sets by transforming the data from the staging layer, which is often usually it's storing this transformed data into operational data store that we call it ODS databases. The integrated data are then moved to another database that often we call it data warehouse database, where the data is arranged into a sort of a hierarchical groups that we usually call them dimensions and the facts, and also aggregate facts. More about this later. A data mart, as you can see on the slide, a data mart is an access layer which is used to get data out to the users. It is presented as an operation for large size data warehouse, as it takes less time and money to design and build. Data mart is a subsidiary of the data warehouse, So we have the big size, big chunk is a data warehouse, and then we have lots of data marts that are inside it. We can call it, you can see it as a sort of a subcategory or sub-partitions. The data mart is used for partitioning the data, which is created for a specific group of users. So talking of group of users, in a company, we have different departments, as we said, sales, marketing, end users, externals. Not all of these users are interested in the whole data. They are mostly interested on the data that is directly or tightly related to the business or to activities that they have to do day by day. So designing these data marts is going to help us to just maintain the access and the availability of the service for these specific group of users that we are dealing with. So let's have a look at decision support system. So a decision support system is a computerized program used to support determinations, judgments, and courses of action in an organization or a business. A DSS or decision support system sifts through and analyzes massive amount of data, compelling, comprehensive information that can be used to solve problems and in decision making. Typical information used by a DSS includes target or projected revenue, sales figures, or past information from different time periods, and let's say other inventory or operations, anything that is related to this context of the data. So a decision support system gathers and analyzes the data, and also synthesizing it to produce comprehensive information reports. In this way, as an information application, a DSS differs from an ordinary operations applications, whose function is just basically gather the data, collect the data. So DSS can do much more than ordinary systems that they are just gathering the data and storing the data. So the DSS can either be completely computerized or powered by human. So we have two different implementations. We can create an automated system to go through the data, provide regular reports and so on, summaries and so on, or it can be triggered by human or some operators that are trying to create some customized reports and data summaries and so on. So in some cases it might be a combination of these two, some predefined and some of the possibilities that are available to the operator of the system, that they can customize specific reports and so on. So the ideal systems analyze information and actually make decisions for the user. So we have seen many systems that they are recommender systems, predictive systems, and so on, that based on the data gathering, the data gathered, they have been stored, they have been analyzed, they have been summarized. A report, for instance, tells us that this is the estimation for that specific problem. Let's say about now we have so there are a lot of speculations about the interest rate of the banks, or the exchange rate between the US dollar and the British pound. So the system is not volatile, so anything taking effect on this exchange rate, and also it is directly related to the decisions that the government is making, and that it takes effect on the interest rate that the banks are charging or offering to their customers. So a DSS can help us to just have a better understanding of these data fluctuations and so on, rather than just having the historical data in a table. So the primary purpose of using a DSS is to present information to the customer in an easy to understand way. A DSS system is beneficial because it can be programmed to generate many types of reports, all based on the user specifications. So let's say the DSS can generate information and output its information using different plots, by, let's say, bar chart, pie chart, in interactive representations and so on. For instance, for a specific different tasks, revenue, projects revenue, or a written report. So it's quite useful. It's very useful. All right. So DSS guarantees to maintain the data consistency over the time. So it provides a uniform platform that, and also the queries will be responded within an agreed period of time. The data will be stored in a reliable structure that can be distributed or centralized. And the data is available upon request based on credentials and permissions. So not everybody can have a look at the results unless it is directly related to the decisions that it's part of their duties, let's call it. For instance, at our university, we have different departments. We have HR, we have the Department of Computing, Department of Art, and so on. So not all of our departments at the university, they need information about all the students, all the procedures, all the modules, and so on. They only get access to the reports that it is directly related to their work that they are doing. For instance, for me, it's not my business to know, for instance, a student's home address, or HR needs to know about, let's say, the module that I am teaching. Okay, so you can provide a report, you can get reports, you can fetch reports, but something that it is related to your work, nothing more than that. Okay, a database generally provides current information about the organization relating to the underlying transactional processes, but it fails to provide historical and also content-rich information that are often more important to the decision-making process than just only standalone raw data, or let's call it standalone islands of information. That's, we have different tables, we have a pile of data, but these are just some information for us. It hasn't been processed. It doesn't make sense to us. It doesn't give us any value, just the facts. So the data warehouse fills this gap by capturing operational data and processing it in a more meaningful format using the structure that is embedded within it, which is going to be relational database, and ultimately complementing the functions of the database used in the DSS. So not only we store the data, but also we structure the data in a meaningful format related to the business. It's very important to realize that from any data, we can structure the data in millions of ways. However, it makes sense to do it, to structure it in a way that it matches the business requirements, the stakeholders. What do they want? What do they want to get out of this data? What sort of report, what sort of queries they are interested in? And then using the DSS, we can apply multiple functions and get the data that we are interested in. Database is a collection of related data that represents some elements of the real world, whereas a data warehouse is an information system that stores historical and commutative data from single or multiple sources. Database uses online transactional processing, which we call it OLTP, whereas data warehouse uses online analytical processing, that we call it OLAP. In the next session, in the next lecture, we will talk more about this. We have ER modeling techniques that are used for designing database, whereas data modeling techniques are used for designing data warehouse. All right, so database is designed to record data that we have talked about it. So that's basically, it is a repeated comparison, but let's go through it and have a look at it in more details. So database is designed to record data, whereas the data warehouse is designed to analyze the data. So not only the storing the data, but also we can analyze the data. We have facilities, embedded functions, linear function, logistic functions. They're available to us. Database is application oriented, collection of data. In other way, data warehouse is a subject oriented collection of data. So we are not interested to just store the data. We are interested to make sure that it is related for our target, for our aim. So database tables and join operations are complicated because they are normalized. This is the important keyword, normalized. Whereas in data warehouse tables and join operations that we are using, they are easy because they are denormalized. So we will get back to this part later. Okay, so we talked about the ETL process: extract, transfer or transform, and load. You might have heard it: transfer, transform. There is a discussion, there is an agreement and disagreement how it's called. Let's call it ETL and learn more about the content rather than the title. So basically, ETL is a type of data integration that refers to the three steps that are called extract, transfer or transform, and also load. These are used to blend the data from multiple external sources into the system. It is often used to build a data warehouse. So we need these operations to build a data warehouse. So during this process, data is taken or extracted from a source system or a source database, wherever it is. And then we are going to convert the data, which is transform it or transfer it into a format that can be analyzed and stored. That this activity is called loading the data into a data warehouse or any other system. The source system is outside the data warehouse. A staging area is an intermediate storage area used for data processing during the ETL process. So the staging area that you saw in the big chart in the previous one, and you can see it here, you can see it in the middle of this flowchart. It is the stage that basically while the process of the ETL is taking place. Okay, so in data warehousing, data is stored in subject area, which makes it easier to access the data. Additional information describing the data is available, which is called metadata. For instance, nowadays we are using our phones. If you take a photo, you can not only you can see the photo, but also you can get information about the location, the time, the camera information, the aperture, and so on. So there are additional information that are related to the data. Okay, so due to having features such as indexing, partitioning, data recall, and analysis, these activities can be done very fast for having some additional data related to the data. Using data warehouse, we get an integrated and consistent view of the subject area, since naming conventions and formulas are all consistent. So using the rules, following the rules, it helps us that we build a system that everybody, even new colleagues, so those who have joined the system, they can understand the logic behind this implementation. Using data warehousing, we can quickly connect all the external data, let's call it retail data, for instance, that it's coming from an inventory, marketing, even campaigns, distributions, in-store customer behavior, feedbacks, and so on. Anything that is related to it, anything that is any sort of activities, it can be transformed into business intelligence visualization tools fit to gain an insight into the details and the logic and extract some knowledge from this raw data to be able to make decisions for the future to maximize the profit. So any business has an aim to maximize the gain. Rather, nobody wants to, no one is interested to lose money or lose their investors or those who are backing the business. All right, data warehouses typically deal with large data sets, but data analysis requires easy to find and readily available data. A data mart is a subject-oriented database that is often a partitioned segment of an enterprise data warehouse. The subset of data held in the data mart, it's typically aligned with a particular business unit. As I mentioned before, so these different business units, they can be sales, finance, marketing, HR, computing department, and so on. So these data marts accelerate business processes by allowing access to relevant information in a data warehouse or operational data store within days, as opposed to waiting for months and months and months to gather the data that you need. Because if you have a big table, we all have had this experience that there is a text file that it is too long, and if we click on it, it takes a few minutes to open it. But if we have a cluster of these small text files that the data have been partitioned into smaller files, it's like a dictionary. A dictionary is a big book. So if you want to look up a specific word, and if there is no indexing, it takes forever. We have to start from the page 1 up to page 1000 or 2000 to look for a specific item or look for a meaning of a specific word. But if that dictionary is indexed or partitioned, we go through the alphabets and then we can quickly find a specific meaning of a specific word that we are interested in. So by using all these, by using data marts and data structuring and so on, so it helps us that we can reduce the cost of the gaining the information that we are interested in. Metadata means data about the data, or data that describes other data. As I told you, the information, for instance, the photo, that you use your phone to take a photo, there are some metadata that tells us about where this photo was taken, who was, what was the phone, what was the date, what was the location, what was the aperture, what was the f value, and so on. So metadata means data about data. The prefix meta typically means an underlying definition or description in context of technology. Metadata makes findings and working with data much easier. This allows the user to sort or locate specific documents. Some examples of basic metadata are, for instance, the author, what was the date that it's been created, when was modified, the size of the file, and so on. Metadata is also used for unstructured data, such as images, videos, web pages, spreadsheets, and so on. So, for instance, nowadays, if you open a PDF file, you can go to the properties and in the information tab, you can see who was the author, when was the last time that it's been modified, what was the organization that they worked, and so on, who was the license owner, and what are the specific fonts that they used in that file, and so on. So data warehouse metadata are pieces of information stored in one or more special purpose metadata repositories that include information on the contents of the data warehouse, their location and their structure, information on the processes that take place in the data warehouse behind the scene, related to the refreshment of the warehouse with, let's say, cleaning it up or keeping up when we are doing the updates, and so on. Any activity, any operation, it can be stored, and about the activities that has been done on the information on the activities, and so on. Okay, so source data feeds are the inputs that feed the data warehouse. Typically it is sort of, we can call it about application databases and also external data sources, such as, let's call it, for instance, the credit rating data or market segment information. This data can be obtained from many places, like operational databases, spreadsheets, Excel files, CSV files, files, any type of files, maybe private data or any external source. That it can be also internet. All right, so let's start talking about the data warehouse design. So we have different type of schemas. So for this course, we are going to only focus on the star schema. This is what we want to build our data warehouse on. So in the star schema, the center of the star can have one and only one fact table and a number of associated dimension tables. It is known as star schema, as the same way as the structure looks like. We have a core, which is the fact table, and there are all around it there are dimension tables. So the star schema is the simplest type of data warehouse schema. It is optimized for querying large data sets. The fact table mainly consists of business facts and foreign keys that refer to the primary keys in the dimension tables. A dimension table consists of mainly descriptive attributes. This is an important this is important term, descriptive attributes that are textual fields. So we have minimal numerical values, most of them are descriptive. A fact table is bigger than a dimension table. I will get back to it later. Star schemas are easy for end users and applications to understand and navigate. With a well-designed schema, users can quickly analyze large, multidimensional datasets. The main advantage of a schema are, first of all, query performance, and then load performance and administration. It's easy for us to understand what's going on, and built-in referential integrity. All right, and also it's very easy to understand the concept and the components of a data warehouse and so on. All right, so let's move on. So every single one of these main features, these are very important. I let you go through them and gather more information in this context. But if you like, get back to me later about the activities and so on. So we have, in this example that you can see on the slide, we have a star schema where we have a fact table in the middle. This is our fact table, and we have 4 dimension tables on the sides. In a star schema, database design and the dimensions are linked only through the central facts. So for instance, there is no link between this table and this table. All of these dimension tables are connected through the fact tables. And if we run a query, if we ask about a specific inventory, so all these queries can be run through the fact table. So there is only one way of connection through the fact table to extract the data. So I just want to make sure that we are on the same page, just to remember that the dimension tables has to be loaded first when you want to design when you want to import data into your schema. So while loading the fact tables, one should have to look at the dimension tables. So we have information on these. First, we design the schema. Second step is to import the data into our dimension tables, and then we load up the fact table, because in the fact table we have some values that are foreign keys, or basically the primary key on the dimension tables, and we will not be able to insert rows into the fact table if these foreign keys, they don't exist on the dimension tables. So it's very important that we import the data correctly, otherwise we are going to get loads of errors and the process is not going to take place. So in a data warehouse, different type of data is stored. We have detailed data include the actual data as coming from the source. We have lightly summarized data, which represents data obtained from current detailed data. It is summarized according to some specific conditions. We have highly summarized data, which represents data that it is distilled from lightly summarized data. It is always compact and easily accessible. So, as I mentioned before, metadata is the data about the data, right? This includes the data about schema integration, information about the tables and operations that take place in a data warehouse. In terms of archiving data, archiving includes moving data that is no longer frequently accessed of primary systems for long-term retention. Unlike data on primary storage, which needs to be frequently accessed and modified, archive data is retained for long periods of time, and best application for it is it can be searched for when it's needed. Talking about these searching in archive data, we will get back to it, how we can boost it, because if you archive loads of data, so it's going to be a big bunch of data, how we can get access to it. Do you remember when I was looking up a word in a dictionary, indexing? We will get back to it later. Data backup or backup data is used for creating and storing copies of data that can be used to protect data warehouse against data loss. The data can be populated from different sources, such as external remote databases, manually intervention, or a remote connection to another database, let's say Microsoft Access, Microsoft Excel, MongoDB, anything, any data. But we need to create open database connectivity. We need to initialize this connection to be able to fetch the data from a different source, change the data format that meets our system requirements, and then we will be able to gather the data and input them into a system. A data warehouse never focuses on the ongoing operations. Instead, it puts emphasis on modeling and analysis of data for decision making. So data warehouse, it's not good for ongoing operations. It can serve best for the decision making stage. It also provides a simple and concise view around a specific subject by excluding data which is not helpful to support the decision process. The time horizon for data warehouse is quite extensive compared with operational systems. The data collected in a data warehouse is usually recognized with a particular period: yearly, monthly, fiscal year, financial year, and so on, and offers information from the historical points of view. It contains an element of time, explicitly or implicitly. In a data warehouse, the data can be aggregated by categories using a specified in the group by clause while we're implementing a query. The categories may have a hierarchical relationship and also present the granularities of aggregation. So, for instance, in a temporal database, users may choose to aggregate data by day, by week, by month, by every seasonal, you can call it every season or 4 seasons, and so on, every other season, and so on. So we can use data warehousing in many contexts. For instance, in sales analysis, information can be analyzed for pricing decisions or identifying customer segments. In financial analysis context, we can compare actual expenses to budget and key expense generators. They also can be researched. And let's say for human resource analysis, for instance, detailed analysis of a specific employees segments or ways to strengthen employees' commitment and their performance and the company prosperity can also be evaluated. So it has loads of applications. So major characteristics of data warehousing are subject-oriented, integrated, non-volatile, and time-variant. So we talked about them in the previous slides. So let's have a look at the subject-oriented and then integrated and so on. So a data warehouse is always subject-oriented, as it delivers information about a theme instead of organization's current operations. It can be achieved on a specific theme. This means the data warehousing process is proposed to handle with a specific theme which is more defined. These themes can be sales, distributions, and marketings. A data warehouse never put emphasis on current operations. Instead, it focuses on demonstrating and analysis of data to make various decisions. It also delivers an easy and precise demonstration around particular theme by eliminating data which is not required for that specific scenario, for that specific business while they are making decisions. So in a data warehouse, the way data is extracted and transformed is uniform, regardless of the original source. Integration means funding a shared entity to scale the all similar data from different databases. The data also requires to be resided into various data warehouses in shared and generally granted manner. A data warehouse is built by integrating data from various sources of data, such as a mainframe or a relational database. In addition, it must have reliable naming conventions and formatting and codes. Because if we have a database, but we just have names of the tables or name of the columns that are not relevant to the nature, nobody will be able to understand what really we are storing, what is the target, what is the idea, how we can analyze the data when irrelevant namings and structure is being used and so on. So this is quite important to take note as well. So a data warehouse is not updated in real time. As we talked, it's best for analysis. It is periodically updated through the updating of the data. This will protect it from the influence of momentary changes. The data resides in data warehouse is permanent. So we need to do our best to design to the best design that meets the requirement of the business. It also means that data is not erased or deleted when new data is inserted. It includes very large quantities of data that is inserted into modification between the selected quantity on logical basis. It evaluates the analysis within the technologies of the warehouse that is available. Do you remember DSS? Alright, data is organized through different periods. We talked about weekly, monthly, annually, fiscal, and so on. In a data warehouse, data is maintained through different intervals of time that we set. It finds various time limits which are structured between the large data sets and are held in online transaction process. If you remember OLTP, the time limits for data warehouse is wide-ranged than that of operational systems. The data resided in data warehouse is predictable with a specific interval of time and delivers information from historical perspective. We have the knowledge from the previous records from the previous time, so we can make a decision that what would be the estimate value for a specific task for the future. All right, so let's have a look at different data types that we have here in the Oracle. A data type associates a fixed set of properties with the values that can be used in a common column of a table or in an argument of a procedure or function. These properties cause Oracle to treat values of one data type different from other values of data type. For example, Oracle can add values of number data type, but not values of raw data type, which makes sense. In any programming language, we have different data types that are used to storing a specific type of data. For instance, date, and also we have numbers, we have characters, and so on. So we have different types of data that can be used based on the nature of the data that we keep in a column. Number is used to store numerical values, date for the date, and characters is used to keep fixed length character data. Varchar used to store variable length character data in form of strings and so on. So char, C-H-A-R, is a data type that we use it for fixed length of data. So if we have a field of name or family name of a student in a table, it's best to use varchar or nvarchar instead of char, because if you use a character one, it has a fixed length, so we have different family names with different lengths. So we are gonna face problems if you want to use a fixed length of characters. But sometimes for specific fields we have let's say ABC, group number ABC. So in these cases we can use, because we know that the lettering that we are using, the rule that we have applied on that specific column, it meets the requirements of the data type. So we have data types to store binary values, like let's say images, videos, and so on, or files. The most commonly used data type are number, date, character, and nvarchar. I highly encourage you to have a look at the Oracle's documentation and explore each one of these different types and learn about their usage and their applications. All right, so let's have a look at aggregation functions. So what is it? What is an aggregation function? So it is basically a function where the values of multiple rows are grouped together to form a single summary value. So we have, let's say, we want to count how many numbers we have. So we have a group of numbers, count them, tell me one single value that tells me how many items are there. So an aggregate function performs a calculation, one or more values, and returns a single value. The aggregate function is often used with group by clause. Talk about it later. So we have the aggregation functions, we use them in the group by clause, and having is another clause that we use them which are part of the select statement. So in here you can see we have an example that we are selecting sum, which is one of the aggregate functions, some of the values that we have on the salary column from employee table. Another example, we are calculating the count of rows that we have in the employee table, where their date of birth it is less than 1st of January 1970. So there are statements that we can use. There are selected statements. There are other statements that we can use aggregate function within them. Okay, count aggregate function returns the number of the rows in a group. If there are no values, it returns null. Sum aggregate function returns the summation of all the null values, and then it just provides a specific number of values for us. Average calculates the average of the non-null values in a set or a record for each specific columns that we have specified. Max returns the highest value in a set of non-null. So as you can see, all of these commands are not their count or their engaged that specific values if it is not null. Minimum, it returns the lowest value in a specific column if they are not null, they are not empty. The first select command, as we said, it returns the sum of the values. The second one returns the count of employees that they are older than a specific, they've been born later. All right, so let's have a look at two examples just to warm you up a little bit. The top select command returns the number of records stored in the customer table. Select, and then we have the count aggregate function from the schema of the bbw.customer. So from the bbw schema, we are getting access to the customer table, and then we are counting all the records that are there. We can do the same thing, but we can add some conditions. So the where, it's basically a condition that we are conditioning the number of rows that their city is, these customers are based in London. Okay, so what else do we have? We are using the maxed function, and also we are trying to do some operations and then call it something. So when you see as or as, so it is basically we are giving a column name for that. We are giving that column a name, and so in here we have a temporary column. So in here we are selecting maximum of the total from schema of the bbw table ORD. All right, so if you are getting data from the order table, where the order date, it is exactly 21st April 2004. Okay, and we are returning the values. So we have a total function on the we have a total value, total column in the bbw. We have a total column in the order table that belongs to the bbw schema. So this schema is available to you. If you are not familiar, please go and have a look at at the video that I have produced yesterday, the day before, on the Moodle table, and you will get familiar with these default schemas. So we have another example. We are selecting the max total what is the maximum total that we have minus minimum total, and then we call this temporary column as difference. So this total is coming from the order table that belongs to the BBW schema, and we are filtering the data and we are conditioning them based on if the order table is on 21st April. So you can see just by adding a condition, we can filter the data and fine tune it to what exactly our stakeholder is asking from us. All right, so let's have a look at subqueries. So we can create nested queries. So we can have, let's say, select last name from a specific table where we are interested to get the last name of the people that, so just if we just run the first part, we are going to get all the name of employees, right? All the last names. However, if we are interested those who are only working in the sales department, we can just filter it down, select the last names from employee table where their department number, it is basically the department number that the department name is sales. So this is called nested or subqueries. So for the lot of work we need to use nested selected statements to be able to extract the data that we are interested in. All right, so I'm talking about nested query and subquery and so on. So a subquery, it is also called inner query, or a nested query is a type of query that we have a query, we have a query within another SQL query, and they are embedded within the Ware clause. As you can see in here, we have a select and they are bound with each other. They're connected with each other. We have embedded them using a Ware statement. So a subquery is used to return data that will be used in the main query as a condition to further restrict the data to be retrieved. So we talked about the example and so on. So just we talked about inner query. So the outer query uses all these results to, gather the data and then send it to the inner and so on. All right. So we have, what else we have? So in here we have the group by command. So the group by statements, as it names is showing to us, the group by statement groups rows that have the same values into a sort of a summary row. For instance, we can say that find the numbers of employees in each department. How can we do it? Select all the department names and also count of employees, and then so we're getting the data from the different departments, and then we're grouping them by their department names. So in some cases we use group by statement with some aggregate functions like that we talked about them: count, max, mean, average, sum, and so on. We use them together to group the results by we are interested not only to have the sum of the data, but also we are interested to see that what are the sums in different cities, what are the sums of sales in different regions in London, and so on. So we can use this approach. So you can see it in this example that we are selecting the city and the total, and we are gaining information from the customer table and the order table. Remember that we are using this C and O that are referring, so these are aliases for the BBW customer and so on. Remember that. You will see it a lot, and you can use it to simplify the statements that you are writing. All right, from the customer table and the order table, and then we are putting a condition, and we are saying that where the customer ID and the customer ID from the order and from the order table and from the customer table, their customer IDs, if they match, and then we are grouping them by the city. So we are getting name of the cities and the total of the orders based on the cities, rather than just having the sum of everything, just total sums. All right. Okay, let's go. So 2 more slides left. Don't worry. I will try to keep it short. So in here we have a select statement with the distinct aggregate function. So the select distinct statement is used to return only distinct or different values. So inside the table or a column, often so they contain many duplicate values. And some queries, we are only interested into a list of distinct values. The first select statement in here that you can see, we are selecting distinct city from the customer table. The second one, it is basically we are counting all the distinct values that we have from the city, from the table of the customer that belongs to the BBW schema, and then it returns the values that we are interested in. All right, how about this example? We are using subselect, and also we have minimum, max, and so on. So we have a select statement that we are getting the last name and credit balance originally coming from customer table, but we are using a nested query or a subquery using where clause that using the credit balance, we are bounding it, we are conditioning it with another select statement, that select statement max of the credit balance. Credit balance is a column, so it goes through all the rows. It goes through all the rows of credit balance and gets what is the maximum value of the credit balance. And then it is telling us, give me the name of the person that has the maximum credit balance. Who is the guy that he owes us the most? Let's report him and so on and get our money back from that person. So, okay. So for using the Oracle, we have, so first of all, this is it for the week. That's all. So just don't forget to practice the commands that we discussed in today's lecture, and also have a look at the lab sheet and make familiar on the SQL developer environment. The video is already available. Please go and have a look at it. So some more knowledge information in here. This information is already on the Moodle page. So remember your username and password. It is just the first part of your email address. For instance, ab345@gre.ac.uk. That first part is your username and your password. All right. And if you need any information, please give us a shout. There are loads of links on the website, on the Moodle page, and so on. And yes, that's all about it. I will catch you later.